In this lesson, we will build a reusable battle screen that reads creature and encounter data, presents both opponents, lists the player's available moves, and always provides a safe route back to the world. This is episode 8 of our Glimmer Grove series, but it also works as a standalone Godot lesson. If you only came here to learn data-driven user interfaces, download the Chapter 8 Recovery project linked below. You can open that project, compare every file we build, and follow the architecture without watching the earlier episodes first. Today we are building the presentation layer, not combat rules. The screen will show names, resolve bars, move labels, colors, and encounter text. The move buttons will remain deliberately disabled. There will be no damage, winner, turn order, affinity bonus, reward, or opponent decision yet. That boundary is important. A screen can display a battle without owning the rules of a battle, and separating those jobs makes both parts easier to test. Series viewers should begin with the Chapter 7 checkpoint named Glimmer Grove 07 First Companion. Standalone viewers may begin with the Chapter 8 Recovery zip and use it as a completed reference while rebuilding the pieces in a copy. We are using Godot 4.7.1, the compatibility renderer, and an 1152x648 viewport. If your project differs, the ideas still apply, but node paths and inspector values may not match exactly. Keep 3 ideas in mind. First, an encounter is a named situation such as Rook's Friendly Exhibition. Second, a battle definition is a custom resource that stores the opponent and the author text for that encounter. Third, the presentation layer is the scene that turns that data into visible controls. Data describes what exists. The presenter copies that description into labels, bars, and buttons. A future battle controller will decide what happens after a move is chosen. Close Godot before copying the project. In File Explorer, duplicate your Chapter 7 checkpoint folder. Rename the copy Glimmer Grove 08 BattleScreen. Open project.godot from the copy, not from the original checkpoint. This gives you a known recovery point and prevents a mistake in this lesson from damaging the last working build. Press F6 or the Play Project button and confirm the Chapter 7 behavior before adding anything. You should be able to choose one starter, see the companion in the party panel, walk through a doorway, and return. If that baseline is already broken, stop and restore the Chapter 7 checkpoint. Adding a battle screen on top of an uncertain project makes every later error harder to diagnose. In the File System dock, expand Data and select Moves. Right-click the folder, choose Create New, then Resource. Search for Move Data, create it, and save it as bell_chime.tres in the inspector. Set it to bell chime, display name to bell chime, affinity to neutral, power to 7, and add a short description. Repeat the process for steady_glow. Give it neutral affinity and power 6. These are opponent moves, but the screen will not activate them today. Right-click Data/Creatures, create a creature species resource, and save it as 10_Bellwisp.tres. Set its stable id to Bellwisp and its display name to Bellwisp. Set base health to 28, power and guard to 4, speed to 5, and affinity to neutral. Add bell chime and steady glow to available moves. Leave this starter off. The file name controls sorting for humans. The ID is the stable key used by code. In script/data, create a new script named battle_definition.gd. It extends resource and receives the class name BattleDefinition. Export an id, opponent name, opponent species, reward flag, introduction, victory text, and loss text. The exported fields make the resource editable in the inspector. Preload creature species at the top so the opponent's species field accepts only the correct resource type. Add a validate function that returns a packed string array. Start with an empty problems array. If the id is empty, append a clear message. If the trimmed opponent name is empty, append another. If opponent species is null, append a third. Return the problems array. This function does not repair bad content. It reports exactly what an editor or automated test needs to fix. Keeping validation beside the data definition prevents a giant validator full of unrelated special cases. Create a new folder named Battles inside Data. Right-click it. Create a BattleDefinition resource and save it as hearth_exhibition.tres. Set it to Hearth Exhibition. Set opponent name to Rook. Drag Bellwisp from the file system doc into opponent species. Write a brief introduction such as, Rook and Bellwisp bow. The exhibition begins. The victory and loss text can remain authored now, even though Chapter 9 will be the first code that uses it. We could hard code Rook and Bellwisp in main.gd, but that would make every new encounter another branch in a central script. A custom resource lets designers add an encounter by creating data. Main only asks the catalog for a. The BattleScreen only reads the return definition. This is the same pattern you can reuse for quests, shops, conversations, cards, or any other content family. Open script/data/ContentCatalog.gd preload battle definition beside creature species. Add a constant for res://data/battles. Add a private battles dictionary beside creatures. In reload, clear both dictionaries and call the same directory loader once for creatures and once for battles. The catalog owns discovery. Callers should not scan folders independently. Read the loader from top to bottom. Dir access gets every file name in the folder. Sort makes the order predictable for debugging. The loop skips anything whose extension is not TRES. Resource loader loads the complete path. A null check rejects files Godot could not load. Finally, the loader reads the resource's id and stores the resource in the target dictionary under that id. The target parameter is what lets one function fill different content families. Add get battle with a string name parameter. Call ensure loaded. Read from the battles dictionary and cast the result as battle definition. Invalidate. Report when the battle dictionary is empty. Then loop over its values, cast each one, call its validate function, and append every returned problem. This gives the editor, tests, and future build tools one consistent catalog check. Save every file before continuing. Open PowerShell in the project folder and run the focus content validator shown on screen. Do not build the battle scene until this passes. A missing hidden, a wrong script class, or an unloaded resource is a data problem. Finding it now is faster than debugging a blank label after the interface exists. Create or open data/npcs/challenger_rook.tres. Give rook normal greeting text. Set action kind to battle and action id to Hearth Exhibition. Add an alternate line for players who do not have a starter yet, explaining that an exhibition requires a companion. The NPC reports intent with two small strings. It does not know which scene opens or how battles work. Create a new scene and choose user interface so the root is a control. Rename it BattleScreen and save it in scene/UI as battle_screen.tscn with the root selected, open layout and choose full rect. Add a color rect child named Shade and set it to full rect too. Give Shade a dark color with enough alpha to separate the battle from the world without pretending the world disappeared. Add a panel container under Shade and name it Arena. Use anchors or container margins to keep it inside a generous safe area. Under Arena, add a margin container named Margin. Under Margin, add a VBox container named VBox. These containers own sizing and spacing. Avoid positioning every label with hand-entered coordinates. Container-based layout adapts more safely when text grows or the window changes. Under VBox, add a label named Heading. Then add an HBox container named Combatants. Under Combatants, add a panel container named Player Card, a label named Versus, and another panel container named Opponent Card. Give both cards the expand fill horizontal size flag so they share the row. Center the Versus label. Consistent node names matter because the script paths are case sensitive. Inside Player Card, add a VBox container. Add a centered name label, a texture rect named Portrait, a color rect child named Fallback, a label under Fallback, a progress bar named Health, and a centered label named Health Text. Set a sensible custom minimum size on Portrait so the card cannot collapse. Put the words original art slot in the fallback. Complete and test one card, then duplicate its structure into opponent card. Do not claim temporary color blocks or finished creature art. Under the main VBox, add a panel container named log panel with a label named log. Enable word wrapping. Add an HBox container named move row and 4 button children named move 1 through move 4. Add another HBox container named result row with retry and return buttons. We create 4 move slots so the layout does not need to be rebuilt for a creature with more moves, but the presenter will hide unused slots. Select return. In the inspector, search for focus mode and set it to all. Leave retry hidden for this chapter. Keyboard focus is not decoration. It is the current target for enter, space, or a controller accept action. A modal screen that can open but cannot be closed without a mouse is not complete. We will deliberately break this setting later so you can recognize the failure. Attach a new script at scripts/battle_screen.gd. Give it the class name BattleScreen and extend control. Declare an exit requested signal. Preload creature instance and battle definition. Store 1 variable for the active companion and 1 for the encounter definition. The screen receives a snapshot of what to present. It does not own the journey state. Add typed on ready references for the heading, both name labels, both fallback rectangles, both progress bars, both resolve labels, the log, retry, and return. Create an array containing move 1 through move 4 in order. If Godot reports node not found, compare the scene doc with the path 1 segment at a time. Do not weaken the code with repeated get node or null checks when the real problem is a misspelled node. In ready, connect returns pressed signal to a private return to world function. Hide retry and hide the entire battle screen. Starting hidden prevents the interface from covering the world when main first loads. The screen should become visible only after valid companion and battle data arrive through present. Create a present function with 2 typed parameters, the active creature instance and the battle definition. Assign them to the stored variables. Before touching any label, return if the companion is null, its species is null, or the battle definition is null. The guard makes the function safe against incomplete calls. Main remains responsible for deciding whether opening the screen makes sense. Set the heading from opponent name. For the player, copy the species display name, species color, base health, and current health into the matching controls. For the opponent, read the opponent's species from battle definition and present its name, color, and full starting resolve. Notice that the screen copies values into controls. It never subtracts resolve or edits a resource. Loop over the size of the move button array. Read the button at the current index. If the index is beyond the companion's available moves, hide that button and continue. Otherwise, read the move resource, show the button, disable it, and set text containing the display name, capitalized affinity, and power. Copy the move description into tooltip text. Hide unused capacity. Disable visible actions whose rules do not exist. Put the encounter introduction in the log, followed by a plain sentence that turn rules arrive in Chapter 9. Hide retry, show return, show the battle screen, and only then call grab focus on return. Visibility must come first. A hidden control cannot provide useful focus feedback. This order is a small detail that prevents a frustrating keyboard failure. In return to world, hide the screen and omit exit requested. The battle screen does not re-enable player movement or reveal the world HUD itself. Those nodes belong to main. Signals let the reusable screen announce what happened without reaching upward into a specific parent scene. Open main.tscn, add a canvas layer named BattleLayer beside the existing UI layer. Instantiate battle_screen.tscn as its child. A separate canvas layer keeps the battle interface above the world and existing HUD without depending on mapdraw order. Confirm the child path is BattleLayer/BattleScreen. In main.gd, preload BattleScreen. Add a typed-on ready reference to $BattleLayer/BattleScreen. In ready, connect exit requested to onBattleExit. These lines make main the coordinator. The screen owns presentation. Game session owns the active companion. ContentCatalog owns encounter lookup. Main connects those owners without absorbing their jobs. In the dialog closed handler, add a battle branch that also requires game session has starter. Ask ContentCatalog for the action id supplied by rook. If the definition exists, hide the HUD and party panel, call BattleScreen present with the active companion and definition, and return. If any condition fails, resume the world normally. This makes a missing starter or bat a safe refusal rather than a broken modal. Add on battle exit. Show the HUD and call the existing resume world helper. Because the battle screen already hid itself before emitting the signal, main only restores what main owns. Using the same movement resume path also prevents one modal from leaving controls disabled while another modal behaves correctly. Let us create one useful failure. Select return and change focus mode from all to none. Run the project, open the exhibition, and press enter. Nothing happens because no control accepts keyboard focus. The mouse may still work, which can hide this defect during development. Stop the game, restore focus mode to all, run again, and confirm a visible focus outline surrounds return. Now run test/validate battleshell.gd with the Godot console executable and the headless script arguments shown on screen. The test reloads the catalog, creates a temporary session, chooses Bramblebud, loads Hearth Exhibition, instantiates the screen, and calls present. It then checks visibility, both creature names, disabled visible moves, and the return route. The expected result is pass. Battle data fills a disabled return safe presentation shell. This validator proves the data can fill the intended controls and that premature move actions remain disabled. It does not prove the interface fits at gameplay size, that text wraps cleanly, that colors are readable, or that keyboard focus is visible. Automated checks and human play checks cover different risks. We need both before saving a checkpoint. Run the complete route. First, speak to rook before choosing a starter and confirm no battle screen opens. Second, choose a starter and return to rook. Third, inspect both names, colors, full resolve values, and the player's 2 move labels. Fourth, confirm the 2 unused move slots are hidden. Fifth, click a disabled move and verify nothing changes. Sixth, confirm the log says rules arrive next chapter. Seventh, press enter on return and verify the world and HUD return. Eighth, reopen the screen. Mouse, click return. Open the party panel and confirm the companion state did not change. If the opponent card is blank, check the battle id, the opponent species field, and the catalog directory. If Godot reports node not found, repair the scene doc hierarchy and spelling. If enter does not leave, restore return focus mode to all and call grab focus after the screen becomes visible. If the dark shade remains after return, confirm the button calls return to world and that function hides the battle screen before emitting exit requested. Stop the running game, save all scenes and scripts, close Godot, and archive the project as Glimmergrove 08 BattleScreen. The verified recovery zip is linked in the description. Its SH256 hash is shown on screen so you can confirm the download. If you joined only for this topic, that archive is also a complete reference implementation for every node path and script in this lesson. The transferable Godot pattern is simple. Put authored content in custom resources. Load content through one catalog. Let a presentation scene receive validated data and emit signals. Keep durable state in its owner. Keep game rules in a separate controller. This structure scales beyond battles because it prevents interface code, content lookup, and rule decisions from collapsing into one script. In episode 9, we will add a battle controller that resolves one deterministic turn without rewriting the screen. The move buttons will finally request an action. The controller will calculate the result, and the presenter will display the return snapshot. Subscribe if you are following the full Glimmergrove build, and keep the Chapter 8 checkpoint untouched so you always have a clean boundary to return to.